This is Mr. James. He is a skilled network engineer and he is a Cisco certified network associate professional. Recently he got a job in a furniture manufacturing company. His employer wanted to design a network for their new opening showroom. That's why they recruited Mr. James. So if you are in the place of James, how you are going to design the network for the new furniture showroom? If you don't know how to design a network, then this video is for you. In this video, we are going to discuss how to design a network. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 30, How to Design a Network. Learn CCNA with Irash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. In this chapter, we will understand how to design a network by identifying the requirements for an organization. So tell me, how you are going to design a network? Designing a network is very important for a network engineer. Same like troubleshooting. If you want to troubleshoot something, first you have to design something. So if you are recruited as a network engineer for any organization, that is because there is already a network available which is designed by somebody else. Designing the network is the responsibility of the network engineer. As a part of new office opening or expanding the current network infrastructure, a network engineer several times face this kind of situation. They have to design a network that can meet the business requirement for the organization. So in this chapter, we are going to discuss about the designing process of a network. It doesn't need that much complicated skill level, same like a troubleshooting a network, but still it needs some kind of specific analytical skill to design a network. So what is the first step to design a network? The first step is understand the requirements. As a network engineer, you have to understand what is the requirement for your new office or the new network, such as what you are going to connect, how many devices are going to connect, and how many cables are required. All this kind of information you have to understand first. So first let's try to understand the requirement. So the picture at the right side showing the floor map of the new office. Here you can see a showroom area. So in this furniture shop, this is the area where the furniture is going to display to the customer. This is the face of this furniture company. This area is only using to display the finished product so that the customer can buy it. And we have another area which is called the warehouse. So this warehouse is using for what? The warehouse is using to manufacture the furniture. There may be wood, there may be carpenter, and there may be lot of machines they are using to make the furniture, polishing, painting, etc. So we can consider this is basically a factory of this furniture shop where the furnitures are making. So these are the main two areas in the upcoming furniture shop. One is the showroom and second one is the warehouse. Now the showroom has some specific requirement because it is facing to the customer side. And the warehouse has another kind of requirement because there they are going to manufacture the furniture. So depends on this kind of requirement, we have to first understand what are the devices are going to connect, how many devices are going to connect, what are the device we are going to use, etc. So first of all, we will consider the showroom or storefront. There we need 30 desktop computers and 30 IP phones, 20 tablets and 20 printers. These are the number of devices we are going to install at the showroom area. Now if we go to the warehouse or factory section, there we need 60 desktop computer, 60 IP phones, 20 tablets and 40 printers. These are the total number of devices that we want to connect in the upcoming furniture showroom. These are the total number of IT assets. In addition to that, there are the core components such as the Active Directory servers are required, SQL servers required, call manager is required for the IP telephony, primary and backup internet connection is required. Why do we need the primary and backup internet connection? Because if the primary is down due to some reason, then still we have a backup internet connection so that the company will not be disconnected from the internet. That's why most of the organization prefer redundant connection, like one is primary and other one is secondary or backup line. So these are the total requirement that we need to consider for designing this network. So here, if you look at the picture, we have to connect 60 desktop computers, 60 IP phones, 20 tablets and 40 printers in the warehouse area. That means this area. And of course, if you want to connect the IT assets, we need the network cabling. So all this network cable should go to one place where we are going to install the network switch. So in this warehouse area where we are going to install the network switch, where we are going to install the network racks, for that we have to consider a specific IT room to install all of this switch, to install the network rack, to install the internet connection from the service provider. For everything we have to find a secured room which is called MDF. This one. MDF stands for Main Distribution Frame. It can consider as main IT room for any organization. So all of the network points from the warehouse area we can connect into the MDF. Now at the showroom side, there are 30 desktop computer, 30 IP phones, 20 tablets and 20 printers we need to connect. So this is the showroom area. This is where we are going to install all of these IT assets. So all of that network cable where we can connect. So you can tell that, okay, we can connect that cable also to the MDF. That is possible. So what if there is lot of distance between the showroom and that MDF? As you know, the network cable cannot use more than 100 meter. That causes network slowness. So in this situation, in the showroom area, we have to consider one IT room, same like MDF, and that is called IDF. IDF stands for Intermediate Distribution Frame. This is the IDF room we have considered for the showroom area. So it is not necessary that the IDF should be big enough, same like MDF. IDF can be considered as a small room, but it should be secured. MDF is the area that we are going to connect all the critical servers and other services. IDF maybe we are using only for the end user computer connectivity. In that case, a small room can be used as an IDF. And I found in some organization, there is no IDF. Instead, they mount a small network rack on the wall and consider that is as an IDF. It is possible to do if there is no space for an IDF. So in this picture, all the IT asset cabling at the showroom area will go to IDF. All the IT asset cabling at the warehouse area will go to MDF, and all the core components, same like Active Directory, SQL Server, Call Manager and internet connection, everything we will connect at MDF because that is the main distribution frame. So now we have identified where to run the cable for the end user computer connectivity. Next step is calculate switch port. As you see in the picture, we have to connect so many IT devices at the showroom warehouse area. So from this list, we have to calculate how many devices we are going to connect and how many switch port we required. And from that number, we can calculate how many switches we are required. So that's why I said to design a network, we should have analytical skill. So first of all, we can consider the showroom area and calculate the number of switch port required. So to connect the 30 desktop computer, how many network cable we required? We required one cable per device. So that means 30 network cable required to connect 30 desktop computer. And how many switch port we required per cable? Each cable need one switch port. So total, to connect 30 desktop computer, we need 30 network switch port. Now let's go to the IP phone. How many IP phones are there? The total number of IP phone at the showroom area is 30. To connect 30 IP phones, we need 30 cables and 30 network port. So number of port required for the IP phone, it is 30. Now there is 20 tablets. How we are going to connect the tablets into the network? The tablet doesn't have the network port. So we have to consider here the Wi-Fi network. So to connect the 20 tablets, we don't need the cable at all. But we need to consider the Wi-Fi network in that area. So to get the Wi-Fi network, we should install the Wi-Fi access point there. So we can consider 10 Wi-Fi access point at showroom area. So each access point need one network cable and each cable required one switch port. So 10 access point require 10 network port. Now let's go to the printer. There are 20 printers required. Each printer required one network cable and one switch port. So total 20 switch port is required for 20 printers. Now when we go to the warehouse and factory area, there are 60 desktop, 60 cables required and 60 switch port is required. So 60. Then again 60 IP phone. They also required 60 cable and 60 switch port. So another 60 switch port is required. Then 20 tablets. So here tablets are using Wi-Fi. So we have to consider the access point at the warehouse area. By considering the size of the warehouse area, we can consider a 15 access point, so that 15 cable is required and 15 switch port is required. Then there is 40 printers. 40 printers required, 40 network ports. Now when we go to the core component, the Active Directory server is there, SQL server is there, Call Manager server is there, then primary and backup internet connection is there. So all of these services are very critical. So we are going to connect these services directly to our core switch or distribution switch. So if we consider a 48 port core switch or distribution switch, then it is more than enough to connect all these critical services. So now let's calculate the total number of ports required. So at the showroom area we have 30 plus 30 plus 10 plus 20. So that is equal to 90. 90 switch port required at the showroom area. And when we go to the warehouse area, we have 60 plus 60 plus 15 plus 40. So 175. Yes, 175 ports are required at the warehouse area. So these are the total number of switch port required for this organization. So in this area, did you see that we missed something? Let me tell you, we have 30 desktop computer. For that we have considered 13 switch port, and we have 30 IP phones. For that we have considered another 30 switch port. This is the point I want to tell you guys. When we are using the IP phone along with the desktop, we don't need additional port for the IP phone or for the desktop. We can use a single port and connect the desktop as a daisy chain to the IP phone. For example, if this is your IP phone and this is your computer, normally you are going to connect the computer into a switch port and IP phone into another switch port. Here we are consuming two switch port that increase our cost. But the IP telephone has a facility that it can provide uplink to a computer. The IP telephone has two network port. One we can connect to the network switch, and from the second port we can connect the uplink to the PC, so that the PC can work in the data VLAN and phone can work in the voice VLAN. So in this way we can reduce the cost a lot. Here we are saving one extra cable and one extra switch port. That will reduce our cost a lot. So if this is the condition, then we don't want this additional 30 for the IP phone. We don't want this additional 60 for the IP phone. Instead, this 30 can be used for phones and computer, and this 60 can be used for phones and computer. So here the total number of ports required is 90 minus 30, it is 60. And in this area, the total number of switch port required 175 minus 60, that is 115. So the total number of switch port required at showroom side it is 60, and at the warehouse side it is 115. This 60 port required at the IDF side, and this 115 is required at the MDF side. Next step is find out how many switches are required based on the MDF and IDF. So from our previous calculation, we find out that at IDF side we need 60 network port, and at MDF side we need 115 network port. So let's see, this is MDF and this is IDF. So at MDF side we need 115 switch port required. If you are going to consider a 48 port network switch, then how many switch we required? In one switch we get 48 port. When we use two switch we get 96 port. So 2 switches are enough? No, because here we have 115. So let's say we need 3 switch so that it can cover the 115. When we use 3 switch, we get total 144 switch port. We need only 115 switch port. The remaining can be used as a spare port. In case in future, if the company is going to expand the network infrastructure, we can use these ports. And at IDF side, the number of switch port requirements are 60. And when we use 148 port switch, we get 48 port. So one switch is not enough because here we need 60. So when we use 2 switch port, we get total 96 switch port and we need only 60. The remaining can be used as a spare switch port that we can use when we expand the network into next level. So the final count, at MDF we need 3 network switch and at IDF we need 2 network switch. So these network switches are here only to connect the end user computer, end user devices like printers, phones, computer, etc. These switches will be used at the access layer. So what about the other critical devices like servers, Active Directory, SQL Server, call manager, etc. Those devices we will connect at the distribution layer, at distribution switches. So no need to worry about those. One of the another point I want to tell you guys is redundancy. When we design any kind of network, it is better to have redundancy, especially in the critical services and critical network connection. For example, here if you are going to use the distribution layer switch, consider 2 distribution layer switch that can work as a redundant, or 2 core switch, 2 internet connection, etc. Now, how to draw the network diagram? From the previous steps, we have identified how many network cables are required, how many switch ports are required, and how many switches are required. Now let's draw the network diagram of our upcoming furniture company. So here we have 2 rooms. One is the main distribution frame MDF and another one is the intermediate distribution frame IDF. So this is our MDF and this is our IDF. Now as per our requirement, we need 2 internet connection. So one is working as a primary and another working as a secondary or backup line. And these internet lanes connected to the distribution layer. And here we are going to use 2 distribution layer switch as a redundant. If one is fail, still the network can connect to the outside world using the second one. And from the distribution layer switch, we are going to connect the access layer switch. So at the MDF side, there are 3 access layer switch as per our calculation. We took the uplink to the access layer switch from each distribution layer switch for the redundancy purpose. Even one link is failed, even one link is down, still the switch can communicate with the distribution layer using the second link. And when we go to the IDF room, there is 2 access layer switch which is going to connect to the distribution layer switch at the MDF. In showroom area, we need only 2 access layer switch. That helps to provide the network connectivity to all end user devices like printers, desktop computers, etc. Now the question is where we are going to connect the critical services like Active Directory, call manager, SQL Server, etc. And of course, all the critical services we are going to connect to the distribution layer switch. So all the servers and other critical device we will connect to the distribution layer switch. And when we do that, we are not only connecting to one single distribution layer switch. We will take multiple connection. One is from one distribution layer switch and the second connection will go to the second distribution layer switch. And where we are going to connect the access point. The access point we can connect to either distribution layer switch or the access layer switch. It doesn't matter. The access points are PoE devices so that it can get the power from the switch itself. At showroom side access point we can consider to IDF room, and warehouse area access points we can connect to the MDF access layer switch. So this is how we design a network based on our requirement. I hope this chapter is very helpful for you. You have learned how to design a network from the scratch by simply understanding the requirement and the connectivity. This is just an example. By understanding this concept, you can decide large complicated enterprise network for the large companies. So in this chapter, we have learned that how to design a network by identifying the requirements for an organization. Thank you very much for watching and subscribe to the channel for more videos.